This is lesson 8-8, all about surface area. So when we talk about surface area, it's the outside of any 3D shape, all of those faces, areas added up all together. Or we can get surface area of a composite figure, which is what I'm going to show you in my first and third examples today. But first I just want to start out with my 3D cube, okay? If we were going to find the surface area of this 3D cube, how do we go about doing that? Well, we have to think about a few things. One of the ways to think about it is if you were to cover it with paper and have this completely covered so you didn't see the orange at all, or paint the entire square. How much paint, how many square inches of paint or paper would we actually need to cover it? That's what the surface area is. So if we look at this one, all the dimensions on my cube are 2 inches. And so that means that this square, this face that you see, this is one of the faces, right, would be a 2 by 2 square. Well, 2 times 2 is 4, so that means that one of these faces is 4 inches squared. And how many faces does a cube have? How many sides, right? How many sides does it have? 6. So 4 times 6 is 24, so the surface area of this cube would be 24 inches squared, all right? The other way to think about that is with a net. So if I could take apart this box and make it into a 2D composite figure or a net that looks like this. This is my cube net. If I was to take this apart and lay it all flat, it could look something like this, showing all 6 sides, right? So that's another way of thinking about it. If we look at the net and then find the area of the net, then we've found the surface area. So like I said before, this side was 2 inches and 2 inches. So 2 by 2, each one of those squares is 4 inches squared. And then we can multiply it by 6 because we know that there's 6 faces. So, oh, I thought I stopped my video. Oh, goodness. Okay, so the first example, I have a composite figure. Now, composite figure just means 2 shapes into one object, okay? And composite figures can be 2-dimensional or 3-dimensional. Okay, my first example is a 2-dimensional composite figure because we have this like layout of a park and we're trying to figure out how much concrete we need for just the A, B, and C shapes. In other words, this whole part is going to be like grass and we don't want to cover that part in concrete. So we only want to find the area of A, B, and C. So this is kind of surface area, and it's surface area of a 2D composite figure. Because we have a rectangle and then we have 2 triangles, right? We know how to find the area of a rectangle and we know how to find the area of a triangle. So if we calculate each one of those areas and add them all up, we have the total surface area needed so that we can do our concrete pour. All right, so the first thing to do is to kind of separate and think about these shapes individually. Okay, so if we're just going to calculate the area of shape A, so I'm going to write it out like this because we're going to calculate each area of each section and then add them all up, and that'll give us the total area. So for this one, these dimensions are 15 and 10, and the area of a rectangle is base times height, or length times width. You can think of it that way too. So 15 times 10, right? And 15 times 10 is 150. All right, so that is the total area of this. So we need 150, well, let's just call this feet. 150 feet squared in that section. Now, in the B section, this one becomes a little bit more challenging because I don't have dimensions, right? So I've highlighted these in red. We don't know what that dimension is or that dimension is. But we can figure it out based on the other dimensions given in the figure. So just like we did in 8-7 cross sections, when we were trying to find the lengths of the cross section, we're looking for parallel lines, right? So if we look at, for instance, this length is 15 from here to here. That means that this parallel line from here to here, I should do this right angle here also, from here to here would also be 15 feet. So if we know that from here to here, 7.5, that's the one I have labeled, we know that that length also has to be 7.5 because 7.5 plus 7.5 is equal to 15. Didn't draw that to scale, did I? That should be halfway, guys. And then this one up here, we don't know this distance, but we know this distance is 16. We also know from here to here is 10 feet, which means that little dimension has to be 6, because 10 plus 6 would be 16. In other words, like if we did this parallel line all the way down to here, this would be 16 feet also. So sometimes you might have to look at parallel lines to find the dimension before you can actually find the area of a shape. So this one, an area for a triangle, remember, is different. We're still going to do the base times the height. This is the base and the height, the one that's on the opposite sides of the angles. So we would do 6 times 7.5 and then divided by 2. Remember, you can also do 1/2 times 6 times 7.5. Either way, you're going to get the same answer, whatever works for your brain better. So 6.75 divided by 2, I think I got 22.5, yeah. Actually, I'll line that up. 22.5 for that one. Now for C, the C triangle, same formula. We're going to do, I'll write this one a different way, I guess. This one would be 1/2 times 8 times 8. Well, 8 times 8 is 64, and half of 64 is 32. So this one is 32. Now that I've calculated each of the areas of each of the sections, now we can get the total surface area so that we can know how much concrete. So now we're just going to add all these up, which is 4, so 204.5 feet squared. So for my second example, though, now we have a 3D shape, and we need to find the surface area. So remember, just like my cube, I now have a triangular prism, but I'm still going to be looking at all the areas of all the faces of that shape added up. That's what we mean by surface area. So we have to think about first, how many faces does this shape have? Well, we have this triangle right here, and then we have another parallel triangle on the back. So we've got two triangles basically that are the exact same area. And then we have, so I'm just going to write like the two triangles so we can keep it organized. It's really smart, guys, to keep an organized list of each face, like the area of each face, so that you can add those all up. So make sure that you show your work for this so you don't miss a side or something. All right, so we have the triangles, right? Well, in a prism, if you remember from the last lesson, if it's a prism, what that means is the base shapes is whatever shape it's called. So triangular, we have triangles, and then the rest of the faces are rectangles. All right, so we have to think about how many rectangles do we actually have on this shape? Well, we have this top rectangle right here. And that one, that dimension, oh, and I didn't write, yeah, I'm missing my dimension. There we go. This one's 8 inches right here. So this top rectangle of the face is 5.8 times 8. Whoops, better make my decimal lower. 5.8 times, you can tell the difference between the multiplication. That's the area for that one. The two triangles, I guess we can just calculate that now. This triangle is 5 by 3. So for this triangle, we're going to go 5 times 3 and then divided by 2 or multiplied by half. So for these two triangles, now one thing you can think about too is surface area if you have a parallel shape. So this triangle is the same area as that triangle, right? So we're actually not going to we don't have to divide by 2. we can actually just recognize that, oh, there's 2. So the area of these 2 triangles would just be 5 times 3. Because if we flip that triangle, put it on here, we would make a rectangle, right? If that totally confuses you, ignore me and just calculate each triangle. Okay, so each of these 2 triangles is going to be 15 inches squared. And then we did the top, like I said, this one 5.8 by 8, so we did the top one. And 5.8 times 8, what did I get for that? 46.4, okay, inches squared. This bottom rectangle, so if you see kind of this, the bottom of this shape where it's like sitting on the table, this one is 5 times 8. So we have this rectangle, we have one that's 5.8, or not 0.8, sorry, 5 times 8. And then the last face that we have is this back side. So from right here, if you can see that shape. So this dimension right here, right, is parallel to this one. So this back rectangle would be 8 times 3. So now if we calculate these, so we have 40, 8 times 3 is 24, and then I already did all that added up for time, so 100, you should have gotten 125, so I would have had 125.4 square inches, or inches squared. You can write it like with the power or square inches too, means the same thing. So again, what we did is we thought about all of the faces. In this case, this had 5 faces. This shape had 5 faces. So we needed to calculate each individual face and then add all of those up. Now, last example is a 3D composite figure, meaning now we have a 3D shape going on, but it's two shapes that we know kind of put together. So as you can see for this one, we have a rectangular pyramid that's sitting on top of a rectangular prism, right? Or a box. And it looks kind of like a house shape, right? Well, if we calculate the surface area of these shapes up here, these faces and all these, we just need to really think about what are all the outside shapes. If I put my pyramid, in fact, I wonder if that fits. I think it might actually. And then you guys can see it. Okay. See, I hate not being in the classroom with you because I can't show you my toys. Okay, so this isn't exact, but it's pretty darn close. So we have a 3D pyramid on top of the cube, but this one in this case, the dimensions are not a cube because they're not the same. But you get the idea, right? We have to figure out, okay, because this shape right here, even though there's a cube on the bottom, it's gonna have the same amount of faces as my example. I'll erase that for now. So we need to think about how many faces this shape as one shape has, okay? So in other words, this little base on the bottom, right? Because it's like this, and that's not an outside of the shape. If you were painting the whole outside of this, you wouldn't need to paint that inside thing. So it's a little bit different. So we could just count, and I'm just gonna try to label these with it on there. So I'm gonna just count 1, 2, 3, 4. You can kind of see what I'm doing here. So there's 4 right there that would need to be covered for surface area. 5, 6, 7, 8. So I have all of those boxes covered, if you can see kind of what I'm doing there, making sure I get them. And then 9, we would have to remember the bottom is that surface area too, unless in a problem you're actually talking about, painting a house, in which case, real life situation, you wouldn't be painting the bottom of the house. Unless you're Mrs. Pigglewiggle. And no one will get that joke, but maybe someone can Google her and make me really happy and figure out who that is and why I said that. Because you guys have so much time on your hands, right? So this shape together, this composite 3D figure has 9 faces. So what that means is we need to make sure that we figure out all 9 areas as 2D shapes, 2D faces, and then add all of those up to get the surface area. All right, so a couple things just to remind you about triangles. This triangle right here, this shape is an isosceles triangle. These lengths are the same, and then we have the height. Remember, you're not going to do this length times this length when you have that type of triangle. We want to actually do the height, which is 15 in this case. So for this triangle, so this is the same, this would be 15, but this dimension, right, would be different because if this is 20, this is 20, right? Those are parallel. Same thing with this. If this is 10, then this is 10 because those are parallel. So we'd have to calculate 15 times 10 divided by 2 for just this face, right? That one face. And then we know that this other side, it's going to have an identical one. And then same thing with this one. This triangle right here on this side would be 15 times 20 divided by 2. But then we also have an identical one on that other side. And then you have to calculate each of the squares. So this would be 20 times 10 for this. And that has a buddy on the back side, right? This is so hard to show you. Draw it like that so you can kind of see. So think about all 4 of those shapes, and then the bottom is also going to be 20 by 10. So what I would do for these problems, guys, is make sure you know the amount of faces first. Okay, so I would just like label it, even like this. 5, 6, 7, 8, 9. I don't know if you can see that, but just like 1 through 9, and then be like, okay, the area of this face is this. The area of this face is also this. You might have some duplicates, right? Then these, because these top ones, like the first 4 that you do would be triangles. And then all of these, the 4 and 5th one on the bottom, you'd have 4 triangles that you're finding the area of and 5 rectangles that you're finding the area of, and then you'd have to add them all up. So if you pause the video right now, see if you can calculate, test yourself, see if you can calculate the surface area of this composite shape, and then I'll tell you the answer. So pause. Okay, so if you did it correctly, you should have added all of yours up to, what did I have? 1,450 centimeters squared.